Good evening and welcome to Lab 3. I kind of just start labeling the lab numbers by the number of videos I've made on my channel so far. Tonight, I'm interested in looking at, do different brands of tubes sound different in an amplifier? In my case, a guitar amplifier. One of the myths that I keep seeing on the discussion of the gear forums is that tubes from China don't sound good. They're fake tubes or they don't have any musical content. And then the opposite is people claiming that some tubes are magic, like these new old stock tubes. They have a better sound or they just sound vintage or warmer. And then some people say some kinds of tubes sound darker, or I see the phrase really brings out the character of the amplifier. And then the other side of the science says, well, no, the tubes don't actually make a difference. I mean, within reason. There's always the case if you have a tube that's been on and used for a very long time, like maybe the metal inside the tube would, lose some of its properties, so it wouldn't emit properly like it used to. So I wanted to know for sure, what is it? Is it actually changing the brand of tube going to make a difference in your amplifier? And I tried listening to other samples on YouTube. There's a lot of videos on this, but to me, they always sound the same. Now, this might be because, on YouTube, there's encoding of the videos and compression, and they do their own like leveling to make sure the sound sounds well for the viewer. So if there is any subtle changes of either volume or tonal character, those changes are probably lost in the comparison video anyways. So the purpose of my experiment tonight, I want to come up with a way that I could test and measure and demonstrate the effect of different tubes, but on the same amplifier. Now, I don't really have an amplifier set up that I want to tinker with by ripping apart, but I wanted to create a simple amplifier circuit that makes the use of its own tube. And this is to isolate the effect that other tubes and transformers in the amplifier would have on the sound. So then with this setup, I could basically measure the response of the tube, but without depending on making sounds and sound clips that I'd have to share with you. So I want to have a way where I can either visually measure the tube responses. So my approach was, I sat down and built a simple tube amplifier that uses one single 12AX7 tube. There's no effects, there's no tone stack, and there's no output tubes, but I decided to use an audio output transformer. Now this would kind of simulate the expected response that we would hear from a tube amplifier. This is basically a simple Class A amplifier circuit using a 12AX7 tube. We have the input, which is capacitively decoupled from the signal. This is to prevent any DC voltage that happens to be on the signal from changing the bias going into the grid of the amplifier. For B positive, I used a charge pump circuit to create me about 350 volts at a very low current, and then a plate load resistor of the standard 100K like you would find in a guitar amplifier. Then a capacitor to decouple it to the gain stage. This is a volume control basically. And then I basically duplicated the exact same circuit here again, but this time I have, instead of a capacitor as the output, it's the output transformer, which I hook up to the line input. So rather than playing music, I decided I'm going to try to test the amplifier's frequency response. And to do this, I'm going to use a signal generator, which is just an electronics test equipment. It can output square wave, sine wave, different kinds of waveforms, and you can control the amplitude and the frequency. In this case, I'm going to do something called a sine wave frequency sweep. Now what this means, I start off at a low frequency, in this case 20 hertz, and then over the period of time, like 4 seconds, I'll have the frequency slowly increase linearly, and then the output of that frequency will be sent into the amplifier. That's the circuit from the previous page. And I have 2 oscilloscope channels set up so I can see what the wave looks like coming into the scope, and a second channel to show what the signal coming out of the scope will look like. So if the amplifier was going to sound different by changing tubes, I would expect that by looking at the output frequency response from the input sweep should look different. So this is my amplifier. This is a tube on a socket with some insulated wires into a breadboard. And these are the capacitors and resistors for the first stage, and this is the second stage. This is the audio output transformer. This is the charge pump that creates from 12 volts in, gives me 350 volts to power the plate. This is my volume knob. This is the input jack from the signal generator. And it's off the screen here, but this is the output jack that goes to a patch cord to my audio interface. So for the frequency response test, I'm using a sine wave, 100 millivolts, peak to peak. And I'm sweeping from 20 hertz to 20 kHz over a time of 4 seconds. Now, this range was chosen because this is a standard, I guess, audio range of frequencies. I mean, any more, any less, we won't be able to hear it anyways. So for optional, I mean, in the previous slide, I used an oscilloscope, so I calibrated the gain because I wanted to make sure the signals look properly, but I don't have a nice way of demonstrating the output of the oscilloscope on my computer. So what I opted to do here instead is the output of the amp into an audio interface. For here, I'm using the Focusrite Scarlett 18i8 third generation, and I've adjusted its gain settings so that the output of my little amplifier creates me about -6 dB full scale on the input. So I don't have any clipping or distortion going on. And then I'm going to use my DAW, in this case is Reaper, and I'm going to record the waveforms of the frequency sweep, and then we're going to take a look at those. So in this test, I have these 4 tubes. These are all branded 12AX7 part number, but they're from different manufacturers. The first tube, 12AX7B, it's just stamped China. I'm not sure. That's just the brand it is, whatever. The second one is 12AX7, but it's branded Ruby tubes. The third 12AX7 is a tongue saw. And this fourth one is a new old stock tube. I believe it's a Mullard tube, but it actually says Holland on the tube. This is Reaper. I have this input set up to record the output from the amplifier, which is being fed the frequency sweep from the signal generator. So I'm just going to start recording this. And as we can see, it's kind of hard to see during recording as it goes. I'll just do a few more, then we can stop it here. There we are. So basically this this gray lines depict the actual signals. If you zoom in, we can see it's this is the digitized waveforms that it recorded. And the general height of it is the amplitude or volume of the waveform. Now, this is the range of the frequency sweep. So this is the start of the sweep when it's almost nothing, around 20 hertz, which is consistent with our transformer because it has a lower frequency response of about 300 hertz, right? So we're going to have almost nothing for low end. And then as we get to the mid frequencies, we have this kind of typical mid frequency boost. And then it kind of maximizes here. This is going to be around 700 to 1200 hertz. And then as we approach 20 kHz, it's going to taper off a little bit, but still be higher than we were at the low end. This is sort of what I see for a lot of my tube amplifiers, kind of like a fish-shaped voltage response over frequency. So now, without changing any settings or knobs, I've powered off the high voltage power supply, and I changed the Ruby tube out for the tube that's just branded China on the side. So it's under the same test fixture, and now we're just going to record this one's frequency response. I guess I could mute this because I don't want to hear that on my monitor. Let this run a few cycles. I guess I should say too, in all of my tests, I let the tubes warm up first. It's about 15 to 30 seconds of having the filament having supply, and then I start running the sweep test on it. So this is a tongue saw tube. It's hard because I know the recording feedback of the waveform doesn't look the same as the after it's recording waveform. And this one, it's called Holland tube, but it's actually an old Mullard tube. I think there was some time back in the 60s when I guess the Muller tubes were made in Holland, so they actually stamped the word Holland on the side of the tube. I had this from my old trainer amplifier, so I just keep it for amusement. What I did here is I've taken one section in time of each frequency response and just clipped it, cropped it to align it so that we can see each tube kind of side by side. So first off, the Ruby tube, that's our first tube we tested with, I guess that's our initial waveform. We can see by comparison the China tube, it actually gets a little bit louder in mid frequency range. So I think to our ear, this would sound a bit louder than the Ruby tube. Now moving on, the tungstol tube, it's kind of closer to what the Ruby tube shape was. It's a little less loud than the China tube, but again, there's no increase or bump or different kind of shape at different frequencies. So I would expect this tube would sound almost exactly the same as the Ruby tube. And finally, if we zoom down here, this Holland tube, or my new old stock tube, it actually looks a little bit like it's going to be a little bit quieter. Now this makes sense because this was an old tube. It had a lot of use in my amp and it's kind of burned in. So perhaps like the metals inside of the tube don't emit as freely as they should. But I mean, under the same settings, but without changing voltages or knobs or gain settings, to record the same frequency sweep over the different tubes and to see slightly different responses like this, they're not going to sound different to me in warmth or clarity, is my point. Like other than the slight variation of volume, because each tube does have slight different amount of gain. And in conclusion, these are the results of sweeping all the different tubes. And again, we can see the frequency response starting from the low frequencies going up to the high frequency creates a volume envelope of the shape of this gray pattern that kind of looks like a fish. And the rate of change of the slope of the angle to the maximum and then back down again kind of looks the same across all the tubes. Like some of the tubes have slightly more volume than the others, but that's just, tubes are slightly different in their properties. But I don't think this is a significant difference for changing the tonal characteristics of the amplifier. So in conclusion, yes, changing tubes of the same part number, but for a different brand, in my opinion, does not make a significant change in the quality of the sound output that we will be able to hear anyways. Now, I was thinking after I said this conclusion, it's possible that a different part number, such as in the 12AX7 family, we have ECC83, ECC803, 12AT7, and 12AU7. Now, these tubes do have slightly different characteristics. So if we were to change out a 12AX7 tube for one of these tubes, well, yes, it most likely would actually sound different and change the sound experience for the user. Here we are. I dug out a 12AT7 tube. It's in the 12AX7 family. It just has a slightly lower gain. Other than that, it's pretty much pin for pin compatible, similar voltages, similar bias current. But we can see here, it does have a slight bit lower amplitude of its output, as well. The bubble of the mid-frequency kind of boost effect that we would hear is not as pronounced. It's kind of closer to, it's closer to flat than the other fish-shaped tubes of the 12AX7. So this would for sure have a slightly different tonal characteristic in an amplifier. This is a JJ ECC803 tube. Now this is ECC83 is a compatible part number to 12AX7. But the ECC803 has a longer plate and its geometry is different inside the tube. So it basically gives, they say it gives a warmer response. And we can kind of see that if we compare the envelope to the other ones, where see like the boost of the mid frequency and low frequency range is much more substantial. So again, that's a slightly different part number though. I mean, if we could find an ECC803 tube from a different vendor other than JJ, I would expect those to look the same as this one. So thank you for watching my video. I have a whole bunch of ideas from doing this video of things I want to try next, including doing a similar kind of shootout for different kinds of audio operational amplifiers. I keep seeing on forums as well that people call them cork sniffers, where changing the op amp can change the output or the quality of the sound. A second video I'd like to try is doing a shootout of op amp versus tube in the application for a guitar preamplifier, which one actually does sound better.